Alright, so we did it till this point, and like to go forward from here. So, did you guys try this question?
We already did this.
I gave this as a homework, no?
No, sir, we did it in class.
Okay, alright, fine. So, then we'll go forward from here. We finished kinematics, we finished center of gravity, we finished Newton laws, right? Fine. And we also did the definition of momentum. So from this point onwards, I would like to go to okay. So we're doing conservation of linear momentum.
Are we done with projectile motion?
Yes, haven't we?
Did you give like all the equations and stuff?
Yeah, I think we're done. Let me see. Yep, we're done. We also practiced some questions. You got to check out the recording then. Probably missed it.
Yes, sir. Okay. Is this in dynamics?
Yep.
Momentum.
Yeah. Dynamics. Okay, so for momentum, we did conservation. We just need to do now. Okay. So, conservation of momentum is basically a law, and the law states that basically it will be asked for 2 points, so you guys need to remember. In the first sentence, you will always write in an isolated system. Alright, for the second point, you're going to write the total momentum before a collision is equal to the total momentum after a collision. Alright, what it really means is that when you have a mass m1 and it is going at a velocity u1, there's another mass m2, it's going at a velocity u2. So that's before they collide with each other or interact, and then afterwards m1 is going at velocity v1, and after m2 is going at velocity v2. Okay, so that's after the collision. So basically what the law says is that the sum of momentum before must be equal to the momentum after, which means that m1 u1 plus m2 u2 should be equal to m1 v1 plus m2 v2. Alright, is it clear?
Yes, sir.
Now this is basically what This is the prime equation that you guys need to remember. So we're going to learn case by case about it. So for example, case 1, when two bodies collide and move away. Okay. So suppose this is M1, 2 kg, U1, 10 meters per second going in this direction, M2, 5 kg, U2 going in the opposite direction, and afterwards M1 with speed 6 meters per second goes here, and we don't know where this goes. Okay, so we got to find what happened to V2. Now the very first step that you're gonna see, or you're gonna basically do, is that you're gonna assign the signs. Okay, I'm going to take positive on the right, negative on the left. You can also do it opposite. You can take negative on the right and positive on the left. But according to this convention, I'm going to put negative signs on anything that has a direction, right? Is it clear?
Yes.
Now, with respect to this sign, if I apply the equation, my equation was M1 U1 M2 U2 M1 V1 plus M2 V2. So the mass was 2, the velocity was 10, in this mass was 5 and minus 20 because of the direction. This is 2 and minus 6 because of the direction, and 5, and we don't know what happened to V2, so we're just taking it as V2 now. So this becomes 20, this becomes 100, this becomes 12, this becomes 5 2. So this will be minus 68 equals to 5V2, and V2 will come out as minus 13.6 meters per second square. Okay, meters per second. So what we really need to understand is that this minus sign, negative, indicates V2 is going to left. Do you guys understand this? Any questions here?
Yeah, no, sir.
Ariba, how are you?
Sir, I'm good. How are you?
I'm good. Better than before. Okay. Now, suppose that you guys decide that I'm gonna take negative on this side and positive on this side, right? And you want, okay, what will happen then? Will the value stay the same? Will it, keep the direction same? So let's check it out. Which means, according to that equation, 2, we'll have to put minus to 10, and this will be 20, this will be 2, 6, and this will be 5, right? Now this is going to be minus 20, this is going to be plus 100 equals to 12 plus 5v2. When we do that, it's going to be 68, 12 plus 5v2, and then it is going to be, plus 68 and v2. Now our answer is going to be positive 13.6 meters per second. Now it doesn't change anything, because if you look at it, this is now a positive sign, and if you have taken positive on the left, so it indicates object is going left. So nothing really changes, you see. So whatever direction you take positive, that's fine. Any questions now?
No, sir.
Okay. Now talking about case 2. Two objects collide and they move in unison. Unison means that there are a couple of words they're going to use, like go together, like stick, embed. It means when they basically hit each other, it means they're going to be one body then. So suppose there is an object 2 kg going here 1.0 meters per second, and that's before collision. Another object moving in this direction which has 3 kg mass and u2 as 4.0 meters per second. After that, they say they collide and they stick together. Sticking together would mean that 2 kg and 3 kg are here, and now they have a velocity which is the same for both. Is it clear? Now what to do? Now in such a case, you just need to write the equation first, which is our prime equation. Now in this one is going to be 2. Let's take this side as positive, this side as negative. So this makes it positive, this negative. We don't know about v, so just leave it. So 1.0, 3 minus 4. When they combine together, you got to add the masses, and now they're going at a single velocity. Is it clear? Now this will be 2, this will be minus 12, this will be 5v. So it means v comes out to be minus 2 meters per second. So this negative, you see the negative indicates that both go to the left. Is it clear? Any questions? Please let me know.
No, sir. It's clear.
Right. Okay. Now, in case 3, just hold on a second, please. Okay. Now going back. So what happens is that case 3, when a stationary body recoils or explodes into, what I mean by this is, usually what happens, like you guys play any shooting games?
Yes, sir.
Which game do you play?
Warzone currently.
Okay, so you might have noticed when you fire a weapon, your aim goes up, right?
Yes.
So that is called the recoil effect. What I mean by this is, like for example, if you talk about a cannon, in a cannon, so the cannonball and the cannon are right now one mass, right? So let's say the cannon has a mass of 5000 kg and the cannonball has 600 kg, and right now the velocity is 0, stationary. The moment cannon fires the ball, the cannon would actually move in the opposite direction. Let's call this 5 meters per second, and the cannonball will be fired forward. Is it clear?
Yes, sir.
Now, say we want to find v2. We take this side as positive, this side is negative. So this makes it the negative, other as positive, because we already know it's going forward. So when we write the equation m1u1 plus m2u2, m1v1 plus m2v2, because initially both of them were at 0 velocity, so this will be 0. Now this will be 5000 minus 5 plus 600 and v2. So this comes out to be as 42 meters per second. So that's the speed of the ball, or the cannonball that was fired. Is it clear? So the movement, when it moves backward, that's basically when you need to understand that means that's the recoiling effect. Okay.
Okay, sir.
Okay. Okay. Now, so in any question, if they say, like they give you an example of a collision and they say, okay, please explain how momentum is conserved. So you guys need to always remember that the law in physics does not break, which means that an example, suppose a bomb goes off, which means there's a bomb that's ticking right now, no velocity yet, and when it goes off, the pieces go in all directions, right? Like this, because the explosion has happened. Now, if we say in the first part, the sum of momentum before is actually 0. So according to the law, the momentum before and after of a system should be the same, conserved. In the explosion, you see the particles are now moving. So how would you explain this? Why is the momentum 0, or is it not? Yes. Okay. Yes. Do you think the momentum is 0? Burhan, Safir, Riba. Give me any answer, please.
Sir, could you repeat the question? I went to get some tissue.
I was saying that if there is a bomb that basically is sticking, so momentum is zero. When it explodes, the particles of the bomb basically go in all directions. So according to the law, the momentum before should be equal to the sum of momentum afterwards. Is it the case here? Or is it not following the law?
I think it is.
Okay, how? How does it follow the law? The law is being followed because, you know, momentum is a vector quantity, which means that if you have a momentum mv here, then you will also have mv on the opposite side. So when you add all these directions together, the sum of momentum after will also be zero. Do you understand?
Yes, sir.
Okay. In the next example, say in a circus, there are two people, right? So one person is like, the other person is like. So right now there's sum of momentum and they're holding hands before is zero. But when they let go, so this guy is going in this direction and this person is going in this direction. So now they're moving. Is the momentum before and after equal? Yes, please.
Since their directions are opposite, it's also zero.
Yes, that's correct. Because it will have a momentum mv, this will have in the opposite direction. When you add them, the momentum will also be zero. Is it clear, Ariba? Ariba, do you understand? Now we look at rockets, okay? So in case of rockets, suppose there is a rocket that's just about to get fired, and right now the momentum is zero, but when the rocket basically starts to move, so is it also zero or what? What do you say? So you need to always think about the law cannot break. Then what could be the reason that the momentum is still zero? So when you guys need to understand that if you've seen, rocket, going towards the space, just recently fired. So the gas has a mass it's pulling out at a certain velocity, and then the body itself has a mass that's also pulling out with this velocity. So when you add both of them, the momentum becomes zero, right? So it's like every time it will be the same. But have you ever considered in space, you might have seen that the object basically it's in space and there's no oxygen, so they need to move it. So how do they do it? Have you realized that ever? Have you seen NASA space shuttles fired in the space? The videos, anyone?
Yes, sir.
So you might have also noticed that they basically drop the load, like parts of the rocket just disintegrates from it. Have you seen that? Is there a reason for
Yes.
it? Why do they do that? So they do it,
Are useless?
yes, because they do it so that if when the mass basically is pushed backwards, the momentum of the rocket increases because it's pushed forward, right? Do you understand? That's how you speed up the rockets. Any questions then?
I have a question.
Yes.
Wouldn't that do like extremely little to help the speed?
Come again.
Like, sir, how will like reducing that much mass and sending it back, increase the speed?
Yes, that's correct. Because there are two laws in effect, right? So basically, what you're saying is that when you push something backwards with a certain amount of force, right? So the equal and opposite force also acts. You agree to this? Right?
Yes.
Now, think about it in this terms. So we have always learned from Newton's third law that the force is equal to ma, right? Now, if the rocket has the same force as the object that was, thrown back. So if I divide the mass here, so you see acceleration and mass have an opposite relationship, right? Inverse relationship. So by reducing the mass of the rocket, you basically increase the acceleration for the same force. Do you understand?
Yes, sir.
So it's not like we're increasing the force, we're reducing the mass to increase the acceleration. That helps us increase this change in speed. Do you understand?
Yes, sir.
Okay. Ariba, are you there? Now, so basically, now I'm gonna give you guys a worksheet, okay? I want you guys to do this worksheet, and there are a couple of questions you're not supposed to do though. The rest of them you're supposed to do because previously, right, the momentum was not part of AS. It was basically part of A2, and now they've split it into AS and A2. Some portion we're gonna do it in AS, some portion in A2. Okay, so I'm putting it in. I want you guys to basically do this worksheet, and tomorrow we will